Gentlemen, here we have a video recording of another experiment, and according to our lab manual, this is the experiment number 6. Its main title is given to you, the specific heat of a liquid. So in this experiment we are going to study about the specific heat for a given liquid, and in this experiment we are going to give you the glycerine. The liquid which you are going to measure in this experiment is glycerine. As you are seeing the objectives of the experiment, when you are going to complete this experiment, you are going to determine the specific heat of glycerine. Gentlemen, this specific heat is the special property of the materials by which they are absorbing the heat energy. So in this experiment we are going to convert electrical energy into heat energy. So you can see in the theory of this experiment that the electrical energy which is doing work, it is generating heat energy by using the current through the resistance or the coil which is immersed in the calorimeter, and that is converting electrical energy into heat energy. So the work done formula is given to you, and in this formula you can see the current, resistance and time. In this you are also using another factor, that is the Joule's constant. Joule's constant. What is Joule's constant? 4.18 joules equals 1 calorie. So you are also observing this unit of heat energy in this experiment. The specific heat definition is given to you, the amount of heat required to raise the temperature of a mass of 1 gram of a body to 1 degree Celsius. And the rule is showing you that heat energy equals mc delta T. This rule is also showing you that heat energy is directly proportional to mass and to the difference of temperature. So and C is showing you the specific heat of the object, and here in this laboratory activity we are measuring this in calorie per gram degree Celsius. Then specific heat formula, because this formula is generated by combining heat energy and electric energy. So we are getting the final formula for this, C equals I square R over S J M minus M E over M. The parts which you are seeing in this formula, ME is the water equivalent of calorimeter, and that is the constant value. What is that? This is the amount of the water that would absorb the same amount of heat as the calorimeter per degree temperature rise. Then M, the mass of the liquid. We are giving you the glycerine liquid, that quantity is 250 grams. The current which is passing through the coils is 2 amperes. J, the constant or this is also called the mechanical heat constant, Joule's constant, both names for this, or even for this is also used for electrical equivalent constant. And in the last you are seeing we are using two coils. I will show you in the calorimeter. Each coil is 1 ohm. So after this we are moving towards the apparatuses one by one, but before this I will just read for you that we are using calorimeter containing the liquid with a heater, or this is also called the electric calorimeter, thermometer, laboratory thermometer, or simple clinical thermometer is also used, ammeter, the ampere meter. In my last video or in the last experiment we have done this ammeter, same we are using over here. Rheostat, also this is the same device which we have used in the last experiment number 5. Digital power supply, and the last one is the stopwatch. So we are moving towards the apparatuses. Okay gentlemen, so we are going to describe the apparatuses which we are using in this experiment. The first one I have just shown you, this is the electric calorimeter. This electric calorimeter is the insulated vessel which is used for measuring the amount of heat absorbed by the material which is inside this, and this is the electrical calorimeter. So I am just going to open for you. You can see this, the two coils which you can see inside this, and this is the cup which is containing the liquid, and we have used this cup. This is the glass cup, and outside is the plastic insulation just to maintain the heat, and inside this you can see this is the moving part, this is the mixer, or this is also called the stirrer, to mix the liquid to make it uniform. And at the center you can see this thermometer, this is the bulb which is containing this mercury, and when this is rising you can see this blue line is moving. In sometimes it's a red line, and the scale is just described on this glass tube. So you can see scale is starting with 0, then 10, 20, 30, but in middle you can see the 5 is there. So that means 0, 5, 10, 15, 20 like this. So each one small line which you are seeing, this each one line is 0.02, because the least count of this thermometer which you are using in this lab activity is having least count of 0.02 degrees Celsius. So this is the measuring setup which is fixed with this glass tube. You can see this, as long as this blue line is moving you have to note down its movement, and wherever it's residing you have to note down the temperature. We are going to use this stopwatch. This stopwatch is used to measure the time. In this experiment we are going to measure the small breaks or small intervals of time by using this stopwatch which has the buttons. So you can see this button. This button is showing you start and stop. So if you press one time it will start, press second time it will stop, and this button is reset to 0. This stopwatch can measure from left side, first one digit hour, then minute, then second, and in the last 1/100 seconds. So the least count of this stopwatch is 0.01 seconds. Gentlemen, I have mentioned some other equipments the same digital power supply which we have used in the last experiment. We are also using the same digital power supply in this experiment, but along with this, in our laboratory we do have this another model of power supply, digital power supply, which is single power supply. You can see this. So inside this you can see the same connectivity is mentioned, red for positive, black for negative, and green for ground. And this has also 2 panels and 4 knobs are there. So the right hand knobs which are mentioned to me, this for current, first one, second for the voltage, and the same other also. But the screen which you are seeing, the first one screen is showing you the current and second screen is showing you the voltage. So this we can also use in this experiment. And then the last, this rheostat, this is the same variable resistor which is used in the last experiment. In this experiment we are going to use this for maintaining the current which is supplied to this calorimeter. So gentlemen, this is all about the equipments which we are using in this experiment. The same ammeter or ampere meter, in our last experiment we have discussed this in details. So same procedure will be used for this also. Okay gentlemen, so I have shown you the apparatuses. After that, see this circuit which is going to be used in this experiment. So we are using this battery, the digital power supply I just mentioned to you, then rheostat, and then rheostat is connected to calorimeter. Positive end of the battery, this will be connected to a ammeter, and ammeter will be connected to the battery. So keep in mind, I have shown you this same calorimeter, and I have just mentioned to you, you can see the 2 coils inside this. So the same 2 coils are mentioned in this picture, the coil 1, coil 2, and they are connected internally to make them in series for the 2 ohms, and inside this oil or glycerine is placed. So this circuit connectivity is a very simple connection which is shown to you. Stirrer or the mixer, I just show you, this mixer or stirrer is placed inside this. Why we are using this? Because the coil, around this coil there will be heat generated. So by mixing, the temperature will be made uniform throughout this liquid to have good results, and thermometer is inserted which I just show you in this calorimeter. So gentlemen, let us go to the circuit connection and start our experiment. Okay gentlemen, so let us start to connect the circuit as we have mentioned in the picture. So I am going to start according to the picture, starting from the positive end of the battery, and this positive end is coming to A, the ammeter. So positive end of ammeter is connected here, and then negative end of the ammeter is connected to the calorimeter. Gentlemen, keep in mind, I am just showing you again this. So you can see this 4 holes. 4 holes are just shown to you. So these two will be connected to make them in series, and these two will be connected according to the circuit. So just by showing you, I am going to connect the two coils in series. So you can see this, that I have connected these two holes by using this small wire to connect these coils in series. After this, the wire from ammeter is connected to the calorimeter. I am going to connect negative end of the battery to the black terminal of the rheostat, and then red terminal is connected to calorimeter. So you can see the all four holes of calorimeter to the common connection, and the two are given to the circuit connection. So gentlemen, my circuit is complete now. After this, be careful in this. Before starting the current, you have to note down the initial temperature, and keep in mind this must be immersed into the liquid, because we want the liquid initial temperature. So before starting the current, you have to note down this mercury or this blue line to the scale wherever it is. I have already shown you the scale for this, that least count of this thermometer is 0.2 degrees Celsius. So each one line is showing you this 0.2. So you have to measure the initial temperature. So after measuring initial temperature, you can start the current. And as we have mentioned that you have to measure, or you have to use the current up to 2 amperes. So gentlemen, this rheostat is used to control the current. So from the main source I have given the supply, but current control is done by the rheostat. So you can see the 2 amperes. Scale I have used 3 amperes. This 3 amperes. So you can read the down scale. So the 2 amperes current is supplied. So after supplying the current, you have to start your stopwatch. So starting this, and then gently you have to mix this. Liquid. So you can see I am just mixing this liquid. So keep in mind my starting time was 0 seconds, and after that every 2 minutes I will note down the temperature in this thermometer. So the thermometer temperature or mercury will rise. So in every 2 minutes we have to read the temperature change. So gentlemen, keep in mind you have to mix continuously. If you don't mix continuously, the liquid temperature will not be uniform, so you will not having good results for the experiment. Okay gentlemen, as you have seen that we have started our stopwatch when we started the current, and I just mentioned to you that after starting the current your stopwatch is started. So, every 2 minutes you have to note down the rise in temperature. So, you can see here my stopwatch is showing me the 2 minutes. So, I will read this temperature in the thermometer and note down in my table which is given to you. So, the first reading was the starting 0, then the second reading for the 2 minutes. Then again you have to mix continuously up to 4 minutes, because every 2 minutes we will note down the temperature change. So, 2 minutes, 4 minutes, 6, 8 up to 20 minutes we will perform this experiment. And one more thing gentlemen, keep in mind, be careful when you start your current and you start your reading. So, your reading should go continuously up to 20 minutes, no break. If you do break, your reading or difference will have some problem, so you will not get good results. So, be careful when you start your experiment. Once you fix all the things, start the current, then continuously you have to go from 0 to 20 minutes. So, now 4th minute is going to be, now at 4 minute again I am just going to see the change in temperature and note down that. So, at every 2 minutes you have to note down temperature up to 20 minutes. Okay gentlemen, so as you have seen, we have performed the complete experiment. So, here is the table which you are going to fill like this. Before starting the current you have noted down the temperature. So, I have noted down the temperature, it was 20 degrees Celsius. Then I started the current, and after 2 minutes, and also keep in mind at 0 minute you have the same as a T1 and your difference will be 0. Then after 2 minutes you can see the temperature rise, T2 I have noted, 4 minutes. So, up to 20 minutes, we will note down the T2, and the last column is showing you the delta T, the difference in temperature. So, gentlemen, keep in mind our stopwatch was reading in minutes. So, every 2 minutes it was easy to note down, but for the calculations and for the graph we are going to follow the time in seconds. That is why we have given you this column for the seconds. So, reading up to 20 minutes you will follow the difference in temperature and then plot a graph between delta T, the difference in temperature, and the time in seconds. So, be careful, we are measuring in minutes, but in calculations we are using time in seconds. So, by following this scale you will plot a straight line and then you will calculate the slope. You will calculate the slope as it is given in the formula. So, after this you have the calculation. You have the calculation for the C, specific heat, I square R divided by Sjm minus Me over M. So, gentlemen, in this formula all values are constants which are given to you, only S slope we have calculated from the graph. So, putting the all constant values which are given to you, you will calculate the specific heat of this glycerine which is given to you in this small cup of calorimeter. So, keep in mind every material has their own specific heat which is constant for them. Okay, gentlemen, when you are just putting all the values inside this formula and S from the slope, the constants are given to you. So, when you will calculate this, you are going to write the constant value which you have calculated. Keep in mind, we are using here the unit calories over gram degrees Celsius. Even though this specific heat has another unit that we are using in theoretical purpose, but here in this lab activity we have the unit calorie over gram degrees Celsius. So, gentlemen, this is the specific heat of the glycerine which you have calculated in this experiment. Thank you.